Welcome to the Grad Futures Podcast, produced and hosted by graduate students at the Graduate School at Princeton University. I'm Eva Kubu, Associate Dean for Professional Development. We're on a mission to shape new narratives about professional success with a Ph.D. to help graduate students everywhere envision and create their futures. Thank you for listening and subscribing.
I'm your host, Hellen Wainaina, a new media fellow at the Graduate School and a Ph.D. student in the Department of English at Princeton. Roger Dube received his bachelor's degree in experimental physics from Cornell and his Ph.D. in physics from Princeton. He is a professor emeritus at Rochester Institute of Technology and has held positions at Kitt Peak and Caltech's Jet Propulsion Laboratory, the University of Michigan, the University of Arizona, and Yale University. His areas of research have included cybersecurity, space weather, artificial intelligence, and native science. Roger is a descendant of the Mohawk Turtle Clan and an enrolled member of the Abenaki Nation. He has been involved in Native rights and projects since college, and here at Princeton, he serves on the Princeton Alumni Executive Council and has co-founded the Native Alumni of Princeton. Roger, welcome to the Grad Futures Podcast.
Thank you so much. Very happy to be here.
So I know I've just introduced you, but I wonder if you might introduce yourself. What have I missed? Is there something you would emphasize, re-articulate?
Well, you've certainly hit all of the key points. The real question is what thread connects all of these? Because it's not so obvious, I think. And the answer to that is I'm very interest-driven. I have a lot of things that fascinate me, that intrigue me. I'll hear something in a lecture that I find infuriating, and I'm suddenly off and studying something new. All of the work I did in holographic data storage was done in response to a talk I heard at IBM about compact disks. So they were going to be storing information in ones and zeros that are burned into this plastic disk. And I raised my hand. I said, no, that's not the right way to do it because it becomes very sensitive to scratches. I said the right way to do it is to store the Fourier transform of the information in terms of a hologram. And I was off. I was off running. They gave me money to build a lab and do all this stuff. So it very, very interest-driven and sometimes totally by accident.
I have to admit, I didn't quite follow the ones versus the holographic, but that I will say what I admire and loved about the bios that I read that you've written or other people have written is that this integration between your experience and your many identities. And so I, for example, not being you, I had a really hard time getting your experience in improv into the bio, but let's maybe sink in a little bit more into that question about what is the connection.
Sure.
Let's begin with your graduate education, your journey into becoming an experimental physicist. What was that like?
Okay, so from a very early age, actually, I wasn't even in graduate school. Long before then, I had this deep need to understand things. I grew up in a community that had a lot of miseducation, a lot of superstition about things. And I would press on people to understand why they believed this thing, and they couldn't answer me. And that I found very frustrating. And so I started searching for answers to those things. And pretty soon I was looking for answers to statements made by some of my tribal elders who kept asserting that Native Americans have been doing science for tens of thousands of years, and we've invented these sorts of things before. And so I would politely ask, where's the evidence for this? Because I certainly would love to dig into it. And they said, it's in the language. And I totally misunderstood what they meant. I thought they were saying it's in our stories. In actual fact, it turns out that the science is stored in the language itself. So Native American languages, as are most indigenous languages around the world, is a polysynthetic language. you build a word by describing what the function of the thing is. So, for example, instead of a word for chair, which in English has a historical connection to a throne from way back, in Native American languages, the word for chair is you sit here. Mm-hmm. So it captures the purpose and the function of things rather than some historical quirk.
Allusion, reference.
Yes, exactly. Right. So I thought that was interesting. And then I ran into a fellow who was Tuscarora. That's part of the Haudenosaunee Six Nations, the Iroquois Six Nations. And the Tuscarora word for red fox can be translated into 6 words that are smaller pieces that put it together. And those words are, he must eat his red berries. Now, if you think about that for a moment, that phrase does not conjure up the image of a fox.
No.
It just does not. And so I needed to understand what the heck is going on here. Well, it turns out that the fox is missing a critical enzyme for digesting food. In order to be able to get that enzyme, he has to eat the berry of either a holly bush or a wintergreen bush. And they're both red berries. So he must eat his red berries in order to digest his food.
Right.
The interesting thing about this, and the reason they went to so much effort to capture this knowledge, is that these 2 berries have a very hard outer shell. The seed itself can't germinate unless the outer shell is stripped off or broken. Mm-hmm. So the fox eating the red berry strips off the outer shell, and the seed can germinate, and so the plant benefits as well. So we've captured a codependency, a synergy between 2 totally different species in the language. Well, it turns out that all sorts of science is captured in the language because we did not have the written word for storing a lot of information. It was in the language.
Right. It was in the spoken.
But not in the form of stories. That was not what they were trying to tell me.
Right. I mean, that's a really deep and complex re-articulation. I thank you for that example. So you have this enthusiasm and curiosity for figuring out why things are the way they are, or to sort of articulate them. I mean, what leads you into, obviously that is one path for entering into studying physics, but is there a particular question that you had or, experience in college that formulated itself into this, like, I want to pursue this path?
Sure. So the answer is quantum mechanics.
Oh no, I fear I'm not going to follow again, but I'd love to hear.
It's not that bad. So classical mechanics is very simple to understand because its formulation is based on our physical experience. So you can take 2 balls on a pool table and you can collide them and you can calculate angles and speeds and do all of this stuff. It can be complicated, but very manageable. So things are totally calculable. Quantum mechanics changes that entirely. Everything in the world, actually in quantum mechanics, in a quantum mechanical world, is comprised of waves, not discrete particles. So an electron, a proton, they're not really the hard billiard ball types of things. They are actually waves that extend all the way out to infinity. Fascinating stuff. And so what that means is that everything that we have in existence, the world that we see around us, according to quantum mechanics, is deeply interactive and entangled and extends all the way out to infinity. And that was an amazing concept for me. And so I just had to study this stuff. This was just too tantalizing for me to leave it alone. So I found myself getting into the field and ultimately did my Ph.D. in cosmology.
A theme of our conversations in this podcast has been around student-centered graduate education. And what that means is that sometimes when you come in as a graduate student, you find that your research interests are sort of propelled by, like, for example, the lab you work in that has a project that needs work done. And so your research interests might be superseded by the needs of that lab. Or in the humanities, the example that we've had is, you might take a class with a professor, but that class might not necessarily be sort of directly connected to your research interests. It certainly might be tangential, but the class itself is sort of formulated around the professor's next book or the professor's previous book. and again, you have such an interesting sort of journey into your CV or your career in your life, and it really is interest driven. How did you do that?
I'm stubborn. Thirst for knowledge is something that I've not been able to control. I have a need to understand things. I like to look deeper into topics. I've taught courses where, for example, if you were to look at my publications, the publications that get the most citations right now are actually publications on crime scene investigations. I taught a course for incoming freshmen, undergrads, and I wanted to teach them how to think like scientists and apply the science to interesting problems. The people that are trying to investigate and document a crime scene often contaminate the scene itself or destroy evidence or misplace it, move it around. Very bad stuff. This is not good for any of the interested parties. So as a physicist, my thought was, well, why do we have to send in a human at all? Why don't we use our multispectral imaging of a scene, capture the spectra of any drops of liquid that might appear in that scene, do a quick spectral analysis and identify it as, oh, this is, this particular liquid, this is blood, this is spit, etc. Those are known technologies. We know how to do that. We have multispectral imaging systems that can do that. What I asked the students to do, I said, here's the problem. I didn't tell them about all the multispectral imaging. I said, here's the problem with crime scene investigation. Design and let's build a system that will obviate the need for human intervention into the crime scene. However you do it, I'm not going to tell you how. I will gladly answer any questions. I'll try to provide references where needed, but there is no answer to this. This is the task. So it's trying to stimulate the natural curiosity that people have that has attracted them to science and stimulate it in a way that they are confident that they have the ability to plunge into any topic and do something with it. I don't feel that they should be limited or categorized into a particular area. They should be free to find an interesting problem and tackle it. As long as they've developed the critical thinking skills, have the resources or understand how to get to the resources that would give them the information that they are perhaps lacking, they should feel confident that they can tackle pretty much any problem. All of the topics that my students have developed in their theses over time have been developed in this way. They found something that was fascinating to them, and I simply sort of nudged them along to say, well, how about this? What about that? And challenge them so that they become comfortable with their ability and their resources and their natural talents enough that they can confidently go into a research area that's actually defined by their interests and not by something that's been imposed on them.
Right. I mean, if I could just observe, it seems like a big part of the way that you cultivate entrepreneurship has been to create the space for curiosity to happen. But that, I don't know, am am I wrong? It seems so antithetical in some ways to the experience of being a graduate student. And you have this sort of track record of, as you've talked about, of creating space for students for their curiosity to sort of drive their own interests. So that's reflected in your sort of teaching, but also in the way that your career has unfolded. And my question is sort of, what did you do to put yourself in that position?
I came to Princeton. No, I'm serious. There are a couple of components here that I found uniquely enabling. My Ph.D. degree was in the area of cosmology. It's a group in physics called the gravity group. One of them, Jim Peebles, recently got the Nobel Prize in physics, and he was on my thesis committee. And the faculty in that group, in my opinion, are some of the best in the world because they take a very core fundamental problem and they can explain it clearly enough that a graduate student can look at the problem and say, oh, I wonder if this might be true. And then this other thing branches off. And pretty soon you've got a whole bunch of students working on offshoots of this fundamental problem. That's what I think the gravity group and the faculty there have done successfully, is they've been able to identify fundamental problems in cosmology and astrophysics that stimulate a fascination and a need to investigate further in the minds and even spirits of the graduate students. They light this fire, and the passion becomes really quite remarkable, and it can carry them. Some stay forever in the same basic direction because it's been such a rich vein of research that they can stay there. Mm-hmm. Others find that they can get the same type of satisfaction by diversifying the problems that they're looking at. And so that might walk away from the original area, but nonetheless, you're still applying the very same techniques and you're still doing the same things in terms of exciting people's curiosity and questioning things, questioning reality in a way that they want to go study and learn more. This is what I felt was so remarkably energizing about the gravity group at Princeton and in general the physics department. I thought they were outstanding.
Mm-hmm. I mean, this is making me sort of think in terms of like, what is the value of your graduate education? It's not necessary. It's like the time that you are allowed to really practice and to think about a particular problem, rather than that the value of your graduate education is the job that you get later. And that's what sort of emerged from. Yes.
In fact, I had a conversation with one colleague of mine who told me that he had become very discouraged about his field, his chosen field in which he got his PhD. It was not physics. It was actually associated more with astronomy. But he had become discouraged. And I said, why are you discouraged? He said, because I measure my success by the extent to which I use the techniques that I learned when I was in graduate school. I said, but the techniques span much more than just a few types of textbooks. It's not just thermodynamics and electromagnetism, et cetera. It's not just these topics. Looking at a problem and trying to grasp the significance of that problem and everything about it. And it may not check off a bunch of boxes from the graduate courses that you took, but it does check off important boxes like critical thinking and your ability to engage the physical world with new experiments that have never been done before.
I mean, to me, it sounds like you're describing the difference between a kind of recitation process, like redoing the same thing, or like maybe not regurgitation, versus a kind of invention sort of led project or research question that is sort of responding to a particular need. And something else that we have been sort of exploring as a theme in the conversation that we've been having in this podcast has been the relationship between your sort of scholarly research and its contribution to a particular community or the communities that we live in and that we share. And we've sort of taken a kind of long journey from the beginning of this conversation in terms of the curiosity that led you into experimental physics, which, as you described, has a lot to do with the kind of curiosity you had in responding to what your elders were telling you about language and the encoding of knowledge, scientific knowledge in language. And I'm just curious if you can sort of talk about your experience as a professor, a researcher, and a teacher, and the connection to working on Native rights and sort of advocating for and attracting students from Native communities to think about their contributions and their engagement with the science or the STEM fields.
So that's a big, complicated area, but a very important one. So if you take as a fact, if you trust me and you accept that Native Americans have been doing science for tens of thousands of years, the science was growing exponentially when the Europeans first arrived, and that put a stop to things. The arrival did, because it introduced a whole bunch of new problems that had to be dealt with immediately. If you work with that assumption, then there's something in the Native American cultures that is conducive to scientific thought. There must be a scientific process. What is that scientific process? How does it compare to what the Europeans think of as the scientific process? How is this knowledge transmitted? How is it preserved? And how do you get young Native American students to pursue these types of careers? Because if what I've just described is all true, then there's a pool of talent whose view of the universe is somewhat different than that of conventional European or Western science. And it would be a shame if that resource were not encouraged to flourish. So would you like to get Native American students into the STEM disciplines? At the very first step, you want to understand what the scientific process is in indigenous cultures as opposed to the Western scientific method. You would like to teach the Native American students to develop that same self-confidence about launching into areas that they've actually never studied before, but they're confident because they have critical thinking skills, etc. You'd like to do that in a way that does not detract from the indigenous approach. Finally, the last complication. So that introduces a whole bunch of problems immediately. You've got DEI issues, getting the students into college, doing so in a way that they're not going to be identified as being given an advantage unfairly. These are all big issues. Yeah. They're big sociological issues. But there's another component, and the other component is there's a community back there that the student has left to come to college. The community has a whole host of issues and problems that are facing them on a daily basis. Very little or no access to internet, very poor quality water sources, often contaminated, undrinkable, very scarce farming or animal husbandry types of resources available to them. And the culture is facing continual pressure from the outside world because there is what one could call intermarriage. The students, by sheer numbers, are much more likely to marry non-natives than they are to marry natives. And that is a problem for the community because the numbers are going to go down. And the student often doesn't come back. So it's a brain drain. How do you convince the community that this is something that they should support? They're going to lose their children. The children are going to go off and they're not going to come back. And so you have to find a way to tie the students' research interests back to the community and involve them so that the student ideally is doing exciting research in an area that has direct benefit to their home community. That's the best possible solution. And that's one of the things that I've been working on as part of these programs that I've been trying to design at different universities to get more students into STEM disciplines from Indigenous cultures. And then there's the ever slow process of trying to teach the non-Indigenous world what this is all about. Sadly, there's a lot of predisposed views, preconceived notions of what Native Americans were like, what they are, what the cultural conflict was between the Europeans and the Indigenous communities when the Europeans first arrived. All of these things just raise tremendously awkward and difficult sociological questions. When I was in my first term here, I remember one day I was in the lab with some of the other grad students in the gravity group, and a grad student in the hallway suddenly appeared at the open door with a professor, pointed to me and said, "He doesn't belong here." And the professor immediately took the student aside, brought some of his colleagues in. The professor's faculty colleagues came, and they all explained to the student, everybody in the program here in physics is qualified to be here. Nobody got special treatment. And I never heard another word like that again. So I was very impressed with how the faculty tackled that awkward situation immediately. They did not let that move forward at all. Very, very impressive. I've not seen anything quite done that well since then. That was just so well done. And I even mentioned that to Jim Peebles when I met with him a couple of months ago. I said, this is one incident where I just was so awestruck at the quality and integrity of the faculty. So I think the last thing that's often overlooked is I think it's really important for a scientist to be able to foster these same qualities in the younger generations and to mentor them so that they too become energized and they too can energize their students. And then the process just keeps propagating forward and increasing. I think without that, it's nowhere near as impactful.
Do you have any final words of advice for current or incoming graduate students?
I don't want the expressions to sound trite, but they do. And that is, follow your interests. Really stay with it. Develop the passion, develop the strength, develop the confidence that you need to do this work. And that will open up a wide range of opportunities for you in pursuing a career and positioning yourself in different places to pursue those interests that you might not have seen otherwise, had you just followed a more conventional career path. I'm very much interest-driven, and I encourage that in my students as well, because I think that is ultimately going to be the most rewarding for everybody. So
Thank you, Roger, so much
Okay.
for this conversation.
Sure. We'll talk about improv another time.
Thank you for listening to this episode. This is Associate Dean Eva Kubu again. The Grad Futures podcast is brought to you by the Graduate School at Princeton University. Our team includes executive producer and host, graduate student Hellen Wainaina of the English Department, editorial director, Assistant Dean James Van Wyk, technical director Elio Geo of African American Studies, marketing, promotion, and logistical support by coordinator Amanda Peacock, and audio editing by Francine Henry. We hope you enjoyed this episode. Please rate and review, and don't forget to subscribe wherever you get your podcasts. Thanks again for tuning in. See you next time.